So for this first problem, we're going to verify that f of x, which equals x cubed plus 2x minus 1, has a 0 on the interval from 0 to 1. So the first requirement for the intermediate value theorem to work is that your function is continuous. Now, f of x is a cubic function. It's a polynomial, therefore we know it's continuous. So the first thing we're going to do is just address the continuity. We're not proving the continuity, we're just addressing it. So I'm going to write that f of x is a polynomial, therefore continuous. The second requirement for the intermediate value theorem is that our d value, our height, in which case it's a 0, is between f of a and f of b, so between f of 0 and f of 1. So for me, to do this problem, I have to actually find f of 0 and f of 1. So I'm going to say f of 0 equals, I come up to the function, plug in 0, and it's negative 1. F of 1, go to the function, plug it in, it's 1 cubed plus 2 times 1 minus 1. So 1 plus 2 is 3 minus 1 is 2. So it turns out 0 is in between. So I'm going to say that f of 0 is less than the 0 that I'm looking for. This 0 is less than f of 1. So basically, if I drew this out on a graph, I know that I have a point 0, negative 1, and I have a point that's 1, 2. There is no way for me to draw a graph from here to here that's continuous without actually crossing the x-axis. So I know it's going to happen somewhere in here, and that's what the intermediate value theorem says. So I can say, therefore, by the IVT, the intermediate value theorem, a 0 exists on 0, 1. Okay. For the next two problems, we're going to verify that we can actually get the d value we're looking for, the d value from the intermediate value theorem, that it can happen, and then we're actually going to find the x equals c that makes that happen. So for this problem, we have f of x equals x squared minus 2x minus 8, and we're going to look on the interval from negative 5 to 0, and we're told that there's going to be some c in this interval that actually reaches, when you evaluate the function, a height of 16. So the first step is to verify that that actually can happen, and the second step is to find that value of c. So for the intermediate value theorem, the first thing you look for is continuity, and this is a polynomial, therefore it's continuous. So that's the first thing I'm going to write down. F of x is a polynomial, therefore continuous. The next thing I'm looking for is this value of 16 between f of negative 5 and f of 0? So to find that out, I have to figure out what f of negative 5 is and what f of 0 is. So f of negative 5 equals and f of 0 equals. So if I plug in negative 5, I have negative 5 squared is 25, plus 10 is 35, minus 8 is 27. F of 0 is 0 squared minus 2 times 0 minus 8, negative 8. And you can see that 16 is in between those two numbers. So the smaller one is f of 0. So I'm going to say f of 0 is less than 16, which is also less than f of negative 5. Therefore, the intermediate value theorem applies. That means that I can find some value of x, and we're going to call it c, in the interval from negative 5 to 0, where f of c equals 16. So f of c is c squared minus 2c minus 8, and I'm going to set that equal to 16 to find my value of c. This is quadratic, so I'm going to set it equal to 0 to solve, so I'm going to subtract 16, and I have c squared minus 2c minus 24 equals 0. Factor it, and factors of 24 are 6 and 4. I'm going to do a minus 6 and a positive 4, and that'll give me a negative 2c in the middle. So c equals 6 or negative 4. Now it's important to go back and see if both answers apply or if just one answer applies. The intermediate value theorem guarantees at least one answer. It could be two, but if I come look at my interval, this is my x interval from -5 to 0, only -4 falls in that interval, 6 does not. So C equals -4 is the answer. Okay. One more time with a slightly different version of solving. So I have f of x equals x squared plus x divided by the quantity x minus 1 on the interval from 5/2, that's 2.5, to 4, and we're going to see if we can find where f of c equals 6. So the first thing you look for is continuity. Now this function does have a break in it. There's a, well, it's not removable. There's an asymptote at x equals 1, and you can tell that if you plug in 1 into the denominator, 1 minus 1 is 0. So it's discontinuous at x equals 1, but our interval is from 2.5 to 4, so we actually don't care about that discontinuity. So I'm just going to write down that f of x has a discontinuity at x equals 1, but is continuous on 5/2 to 4. The next thing I'm going to do is actually figure out what my f of a and f of b are. So I'm going to find f of 5/2, and then I'm going to find f of 4. And f of 4 is going to be a little bit easier, so I'll do that right now. 4 squared is 16 plus 4 is 20. 4 minus 1 is 3. So we have 20/3. That's 6 2/3, which is more than the 6, so f of 5/2 has to be less than 6 for the theorem to apply. So I'm going to plug in the 5/2, and I'm going to say that this is 5/2 squared plus 5/2 over 5/2 minus 1. Now to simplify this, I'm going to multiply by a very clever form of 1. So I want to get rid of the denominators of the fractions that are within the fraction. So I want it to be just one fraction. So what you do is you look at each denominator and you want to pick a number that goes into all of them. And you can tell that actually everything does have a denominator. This one looks like it's 2, but it's squared. So this is actually a denominator of 4, a denominator of 2, a denominator of 2, and a denominator of 1. And I know that all of those go into 4. So I'm going to multiply by 4 over 4. And this is going to be a big distribution problem. So 5 over 2 squared is 25/4 times my 4 is just 25. Plus 5 times 4 is 20 divided by 2 is 10 over, and this is the same thing, 10. 4 times a -1 is -4, and this is equal to 35/6, which that number is between 5 and 6, so it is less than 6, and this is going to work. So I'm going to say for my between step, it's f of 5/2 is less than 6, which is less than f of 4. Therefore, we know that the intermediate value theorem applies. Okay, part 2 is to actually find the x value of c that gives you a value of 6 when you plug in. So I'm going to say that f of c equals c squared plus c over c minus 1, and I know that's equal to 6. And it might help your solving if you think of the 6 as a 6 over 1. I'm going to cross multiply to actually turn this from a fraction into something on one line. And what I'm really doing is taking the c minus 1 and just multiplying it over to the other side. But if you want to keep everything straight, just remember you can cross multiply. So c squared plus c times 1 is c squared plus c equals 6 times c minus 1. Now this is a polynomial, in fact it's quadratic, so again I'm looking at setting it equal to 0, factoring, and solving. So I have c squared plus c equals 6c minus 6, and then I'm going to subtract the 6c, add the 6. So this is c squared minus 5c plus 6 equals 0. I'm going to factor. I have c, a c, a 2, and a 3, and they're both negative. So c equals 2 or 3, But if I check my original interval, it's from 2.5 to 4. So 2 does not fit in the interval, 3 does. C equals 3.